Okay, so number 1 says that many professional schools require applicants to take a standardized test. Suppose that 1,000 students take such a test. Several weeks after the test, Pete receives his score report. He got a 63, which placed him at the 73rd percentile. This means that A, Pete's score was below the median. B, Pete did worse than about 63% of the test takers. C, Pete did worse than about 73% of the test takers. D, Pete did better than about 63% of the test takers. Or E, Pete did better than about 73% of the test takers. So, 73rd percentile is the part that matters. So anything about 63 is not important. I don't know the median. I do know that the median would be 50% though. So he did not score below the 50. So, with percentiles, the higher your percentile, the better you are than everyone else. So, E is better. Pete is better than about 73% of the test takers. Okay. Number 2, for the normal distribution shown, the standard deviation is closest to. On this one, the way you would figure this out is, let me grab my ruler. You want to see right when the peak starts to change. So like about right here. Oops. Right here is where the peak starts to dip down. So over here is 3. So our standard deviation is closest to 3. Because it's kind of about there. It's the closest number choice I have. Okay. Number 3 says rainwater was collected in water containers at 30 different sites near an industrial complex, and the amount of acidity, the pH level, was measured. The mean and standard deviation of the values are 4.6, 0, and 1.10 respectively. When the pH meter was recalibrated back at the laboratory, it was found to be an error. This error can be corrected by adding 0.1 pH unit to all of the values and then multiplying the result by 1.2. What are the mean and standard deviation of the corrected pH values? So, what I want to do here is the mean is the 4.60. So I'm going to do the 4.60, add the 0.1 to it. This is going to give me 4.7. And then I want to multiply by the 1.2. So I would do 4.7 times 1.2, which gets me 564. For standard deviation, this only changes when you multiply or divide. So the adding 0.1 to all of my values is not going to affect my standard deviation, but the multiplying will. So I want to do the 1.1 times the 1.2, which gets me 1.32. So this correct answer is B. Okay. Number 4 is saying that the figure shows a cumulative relative frequency graph of the number of ounces of alcohol consumed per week in a sample of 150 adults who report drinking alcohol occasionally. About what percent of these adults consume between 4 and 8 ounces per week? So if I look at 4, this is about 20%. And if I look at 8, this is about 60%. So then what I want to do is I just want to go ahead and subtract my 2% to get 40%. This next one says the average yearly snowfall in Chillyville is approximately normally distributed with a mean of 55 inches. If the snowfall in Chillyville exceeds 60 inches in 15% of the years, what is the standard deviation? So, what I want to do is I know my z-score is my number minus my mean divided by my standard deviation. I don't know my z-score yet, but I do know my area is 0.15. So what I want to do is I want to figure out my z-score, and I can do this by going on my calculator. I'm going to go to VARS, second VARS, and I want to press 3 for inverse normal. My area is 0.15, and then I want everything over 60 inches. So this is going to be, if I have the choice, I want to use right on my calculator. If I don't have the choice, I'm going to do exactly as it is, and then subtract, or change it to a negative. And then I want to hit paste, which gives me 1 point. This is my z-score. So I'm going to do 1.04 because z-scores are always to 2 decimal places. Then I want to plug in what I know into my problem. So I'm going to have 1.04 equals 60 is the number I care about. My mean is 55, and the standard deviation is what I don't know. So I can simplify this to be 1.04 equals 5 divided by my standard deviation. I can get my standard deviation out of the denominator by multiplying by both sides, which is going to give me 1.04 times my standard deviation equals 5. Then I can just divide both sides by 1.04, which is going to give me 4.807, which is closest to A. It's probably because I rounded that I'm off a little bit. So if I'd done more decimal places for my z-score, I would have been closer to the 4.83. Okay, number 6 wants me to look at the figure of the density curve that's not shown. Okay, I have gone and printed off another copy of this, so now that 6 has a picture. The mean of the distribution is E. A, or B, the area between B and F is 0.50. C, the median of the distribution is C. The third quartile of the distribution is D. A, the area under the curve is between A and G is 1. So, without being able to know the height or the percentages of the different heights, I can't say anything about the mean, median, or quartiles. The area between B and F, I cannot for sure say that's 50%, but I do know that if I'm between A and G, my entire curve, density curves always have an area of 1. Number 7 says if the heights of a population of men are approximately normally distributed, and the middle 99.7% have heights between 5 feet and 7 feet, what is the standard deviation of the heights in this population? So, I know I have, pretend I've drawn this much better. So I have my number in the middle. The first 2 out are 68. The second 2 out are 95. So 3 standard deviations out is when I get to the 99.7. So I have my 5 feet and 7 feet here. I need to figure out what my standard deviations are to figure this out. So I want to see how many tick bar, or how many spaces I have in between the tick bars. I have 1, 2, 3, 4, 5, 6. So there's 6 spots in between 5 and 7. What I want to do is I want to find the difference between 5 and 7 and divide by 6. It's helpful if I convert these to inches. Remember, I multiply by 12 to turn them into inches. So this is 60 inches for 5 feet, and I believe 84 for 7, but let me check. Yes, 84 for 7. So I have between 60 and 84, which gives me a difference of 24. I have 6 values I want to divide them by, which gives me 4. So my standard deviation is 4 inches away. So if I counted by 4 inches, I would match up to 7 on the end. Number 8 says the distribution of time it takes for different people to solve a certain crossword puzzle is strongly skewed to the right. So when it says skewed to the right, that means it looks like this, with a mean of 30 minutes and a standard deviation of 15 minutes. The distribution of z-scores for those times is So A is normally distributed with a mean of 30 and a standard distribution of 15. Skewed to the right with a mean of 30 and a standard distribution of 15. C, normally distributed with a mean 0 and standard distribution of 1. D, skewed to the right with mean 0 and standard deviation. And E, skewed to the right, but the mean and standard deviation cannot be determined without more information. So, it is going to be skewed to the right, because the problem tells me it's skewed to the right. So my normally distributed ones are wrong. When it's talking about z-scores, these are when I have standardized my curve. So it has to be mean 0 and standard deviation, because z-scores are standardized. Number 9 says the Environmental Protection Agency, EPA, requires that the exhaust of each model of motor vehicle be tested for the level of several pollutants. The level of oxides of nitrogen, NOx, in the exhaust of one light truck model was found to vary among individual trucks according to an approximately normal distribution, with a mean of 1.45 grams per mile driven and standard deviation of 0.40 grams per mile. Which of the following best estimates the proportion of light trucks in this model with NOx levels greater than 2 grams per mile? So I want to start off by finding my z-score. So I'm going to do 2 minus 1.45 divided by 0.40. Remember, if this was a question on the free response section, I would want to sketch out my graph. It's normally distributed with a mean of 1.45 and a standard deviation of 0.40. And I want greater than 2 grams. So I know my mean is 1.45 and my 2 is here. So I want things off to the right. I'm going to find my z-score. So 2 minus 1.45, oops, I wanted to close the parentheses, divided by 0.40 gets me 1.375. Then I want to find the area under the curve. So I'm going to go second bars, and I want normal CDF. If this was on the free response portion, I would write normal CDF. You don't have to on the multiple choice. And then my upper is my z-score, so 1.375. And then I want to paste and enter. I want to write down what I've also written there, if this was a free response. And it gives me 0.9154, which is not the answer. Just kidding. Because, remember, this will always give me left values. I want to do 1 minus that value. So, 1 minus 0.9154 gets me 0.0846, which is what B should say. It will say the correct number on your copy. Okay. So moving on. Number 10 says, until the scale changed in 1995, SAT scores were based on a scale set many years ago. For math scores, the mean under the old scale in the early 1990s was 470. So this is going to be my mu. And the standard deviation was 110. In 2016, the mean was 510. And the standard deviation was 103. Gina took the SAT in 1994, so the ones I wrote in blue, and scored 500. So this, I want to compare z-scores if I'm ever asked to compare two scores with different scales. So I'm going to figure out Gina's. Gina's going to be blue. I'm going to do her 500 minus the 470 divided by 110. Which gets me 0.27, we'll do 3. Then I want to do the same thing for her cousin, Colleen, and she scores the 530. So I want to do 530 minus her mean of 510 and divide by her standard deviation of 103. So 530 minus 510, then divide by 103. Gets me 0.194. So Gina is further away from the mean. That means Gina scored higher. Her standardized score is higher than Colleen's. Okay. Moving on. Number 11 gives me this dot plot, and it says it's giving the sale prices for the 40 hours in Ames, Iowa sold during a recent month. The mean sale price was $203 and $388 with a standard deviation of 87,609. So it wants me to A, find the percentile of the house indicated by the arrow on the dot plot. So I want to count how many dots are to the left of that, including the dot with the arrow. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. I know there was 40 total houses. So then I want to go ahead and divide 47 by 40. 27 by 40. I really messed that up. Okay, so that gives me 67.5, or 0.675. So I will round up and say the 68th percentile. B wants me to calculate and interpret the standardized z-score for the house indicated by the arrow, which sold for $234,000. So this is an ugly 2. I'm going to do 234,000 minus my mean sale price of 203,388 divided by my standard deviation of 87,609. Oops, I missed it. The comma goes there. Okay. So I want to type this into my calculator. I'm going to do 234,000 minus 203,388. Then divide by my standard deviation of 87,609, which gives me 0.349. So what this means is the sale price for this house is typically z-scores go to 2 decimal places, so 0.35 standard deviations above the mean, or above the average price. For homes in this sample. Number 12 is saying a study recorded the amounts of oil recovered from the 64 wells in an oil field in thousands of barrels. Here are the descriptive statistics for that set of data from statistical software. And then it says, based on the summary statistics, is the distribution of amount of oil recovered from the wells in this field approximately normal? Justify your answer. So, if I take a look, I have my median is, no, not my median. My median is 48.25, and my standard deviation is 40.24. My median is 37.80. My first quartile is 21.40, and my third quartile is 60.75. So if I look at this, there is a huge difference between my mean and median. On a normal distribution, these are close to being the same. So I'm going to say no. There does not seem to be a normal distribution. there is a large difference between the mean and median. And then I would say in a normal distribution, these are the same. Okay. Then I could say the distance between the minimum and the median is 37.8 minus 2. So the distance between the minimum and median while the distance between the maximum and median when I subtract those, I get 167.10. In a normal distribution, these should be the same. So moving on to my last question. It says, a study of 12,000 able-bodied male students at the University of Illinois found that their times for the mile run were approximately normally distributed with a mean of 7.11 minutes and standard deviation 0.74 minutes. So this one is a free response question, and it's asking me how many students ran the mile in less than 6 minutes. So I want to sketch this out. I'm going to have my mean of 7.11. 6 is over here. I want students less than this, so I'm going to shade there. And then I'm going to label. So I'm going to have n 7.11, and my standard deviation is 0.74. Then I want to go ahead and find my z-score. So I'm going to do 6 minus 7.11 divided by 0.74. I want to figure out the z-score on my calculator. Which gives me negative 1.5. Then I want to go ahead and type this into normal CDF. So I'm going to go to second vars. Normal CDF is choice 2. I want to change my upper to negative 1.5. And then go down to paste. Again, because it's a free response, I want to actually write this out. Which gives me 0.0668, which means about 6.68% of students ran the mile in less than 6 minutes. This one wants me to figure out how long it takes the slowest 10% of the students to run the mile. So again, I want to draw a picture. I know over here that because they're the slowest 10%, this is my area of 0.10. And then again, I want to label this as my normal curve. So because I have an area, I want to start off by working backwards. I want to use inverse norm. So second vars, inverse norm. And then my area here is 0.10. I want everything to the right, so if I have that option on my calculator, use it. Which gives me 1.28. If I don't have that option, I believe I just make it negative. Oops. Z equals 1.28. So then what I want to do next is I want to plug this up into the z-score formula. I'm going to have 1.28. I don't know the time, but I do know that the mean is 7.11, and my standard deviation is 0.74. So now this just looks like an algebra problem that I need to solve. I want to go ahead and multiply both sides by 0.74. That is going to give me 0.9472 equals x minus 7.11. Then I want to add the 7.11 to both sides. And I get x equals 8.0. I'm going to round to 2 decimal places because they gave it to me in 2 decimal places, but it's 8.0572 on the calculator. It rounds to 8.06. This was measuring in minutes. Okay. C says, suppose that these mile times are converted from minutes to seconds. Estimate the percent of students who ran the mile between 400 and 500 seconds. So what I need to do is I need to go ahead and change my times into seconds. Remember, minutes to seconds is going to multiply by 60 because there is 60 seconds in a minute. So what I can do is I'm going to take the 7.11 and times by 60, which gets me 426.6 for my mean. And then I'm going to do the same thing for my standard deviation, so the 0.74 multiplied by 60, which gives me 44.4. And then I want to go ahead and draw out my picture again. So this time, my mean is 426.6. If I label it, it's going to be 426.6, comma 44.4. And then I want between 400 and 500. So I want a shade in between. And then I'm going to find the z-score for both of these amounts and then subtract. So I'm going to start with the 400. So I'm going to do 400 minus 426.6 divided by my standard deviation of 44.4. Which is going to give me negative 5. These scores are 2 decimal places, so this should actually be 6.0. Or 0.60. Then I'm going to do the same thing for my 500. So I'm going to do z equals 500 minus the 426.6 divided by 44.4. Which gives me 1.65. Then I want to go figure out my areas for both of these. So I would, for my 400, I'm going to do the normal CDF. going to be negative 1 e to 99 to negative 0.60, 0 to 1. To get that on the calculator, I go second fars, and I choose choice 2, which gives me 0.2743. And I want to do the same thing for the 500. I do normal CDF, negative 1 e times 99, comma 1.65, comma 0, comma 1. I'm going to go type this in. So I go second fars, normal CDF. This time my upper is 1.65, which gets me 0.9505. Then I want to go ahead and subtract these. Which gives me 0.6762. Or 0.6762. And then I want to go ahead and turn this back into a percent. So about 67.6% of students ran the mile between 400 and 500 seconds.